All right, we've got a pretty short lesson today, and this is going to be involving factoring special cases, turning trinomials into binomials. So similar to what we did when we were multiplying, we showed you some special cases. Now we're going to go backwards and again see how those special cases show up. So let's take a look at special cases. First example, it says to factor the following trinomial. So we're again going to do the same process that we learned last week. And we're going to look at the things that could multiply to a 36. And that would be 1 and 36. That would be 2 and 18. That would be 3 and 12. It would be 4 and 9. Or it would be 6 and 6. Lots of different options to choose from here. And we have to find the set of numbers that add up to this middle term. We want the ones that add up to 12. So 1 and 36, 2 and 18, and we get to this one, 6 and 6. So in order to factor this, 6 plus 6 makes 12. We're good to go. It will be x plus 6 times x plus 6. And you might think you're done, but there's still one more step that we have to take. Since it's the same binomial being multiplied 2 times, we're going to write it as x plus 6 squared. And that is our final answer. So the key thing to notice here, when you have 2 binomials that are the exact same being multiplied by each other, you can write it as squared. Let's take a look at one more example. And again, we're going to look at the things that could multiply to a 64. And that's 1 and 64. That's going to be 2 and 32. 3 won't work, but we could do 4 and 16. 5 won't work. 6 won't work. 7 doesn't work, but 8 works. So those are all the possibilities that could multiply to a 64. And now we want the combination that will add together and make a 16. And if we look at 1 and 64, that won't do it. 2 and 32, that won't do it. 4 and 16, that won't do it. So it's again going to be this duplicate here. We have 8 and 8. But the problem is, if we just add 8 plus 8, we get positive 16. We don't want positive 16. We want it to be a negative 16. So what could we do to make it negative 16? Just make them both negative. So if you multiply negative 8 times negative 8, it still equals positive 64, like we want. And if you add negative 8 and negative 8 together, you combine those together, it equals negative 16. So that's the combination we're looking for. We'll write it as our 2 binomials, x minus 8 times x minus 8. And now you know to rewrite it as x minus 8 squared. And this is your final answer. One thing I want to point out, these special cases, the reason they're a special case is when they're factored, they create what's called a perfect square. So in this case, a perfect square means you have something that is being multiplied by itself 2 times. So you have the exact same thing multiplied by itself twice. That's why it's a perfect square. Go ahead and try the next 2 on your own. Hopefully they're pretty harmless for you. And pause the video here. When you're done, come on back and we'll look at one more special case. Before we move on to the next set of examples, I'm going to give you your password a little early. And our password for this one is going to be United. I think sometimes we're a little too divided and it'd be nice if we were all united. So United is your password for this assignment. All right, next set of examples. Factor the following trinomials. Even though they don't look like trinomials, it is a trinomial. Remember, trinomial means 3 terms. If you look at x squared minus 81, well, there's only 2 terms. So let's think of it in a way that we can think of it as a trinomial. It's x squared plus 0x minus 81. So there's that hidden 0x in there that we can't see, but I'm going to write it in there here just so we can figure out how to factor this. Now let's look at all the things that multiply to 81. We got 1 and 81, or we have 3 and 27, or we have 9 and 9. Those are all the possibilities that could make an 81. And I have to find the combination that somehow adds or subtracts to a 0. So if I look at 1 and 81, that won't do it. 3 and 27, that won't do it. 9 and 9, this one could be the 1. But the problem is, if I add 9 plus 9, we get 18. That won't work. So I'm going to make one of them negative. Doesn't matter which one. I'll make the second one negative. If we take 9 minus 9, it now equals that 0 term in the middle. So that's going to be the combination we look for. So our final answer here would be x plus 9 and x minus 9. And hopefully you remember when you're multiplying these, at least with the box method, you end up getting a 9x and then a minus 9x that ended up canceling out. And that's why there's no middle term in here. So this one is x plus 9 and x minus 9. And that ends up having that middle term cancel out. Let's look at the next one, x squared minus 100. Again, I'm going to rewrite it. We have x squared plus 0x minus 100. And then we look at the things that could possibly multiply to 100. We have 1 and 100. We have 2 and 50. You probably don't need to write all these out. You probably already know the right answer, but I'm going to do it anyways. Just a good habit to get into. 4 and 25, 5 and 20, and we have 10 and 10. And we have to find the combination that adds up to a 0. And that's right, it's going to be the 10 and the 10. In order to make it a 0, one of these has to be a negative. So let's put a negative on the second one. So your final factored answer would be x plus 10 times x minus 10. And if you look, one of them cannot be factored. And I'm going to show you the reason this one cannot be factored. I put a big plus sign on here. It should match up with the plus sign on your notes. Let's rewrite this one as x squared plus 0x plus 25. And I'm going to list out all the things that multiply to a 25, and we get 1 and 25, or 5 and 5. And we have to find the combination that could make a 0, and it won't be 1 and 25, but we're going to try 5 and 5. But in order to make a 0, one of them would have to be negative. So let's try putting a negative here. But the problem is, if I have 5 times negative 5, it doesn't make positive 25 like it should. It would equal negative 25. So in this case, I cannot factor this problem properly. So this one, I'm just going to write cannot factor. So when you have two terms here where that middle term has disappeared, you can factor it when it's a minus at the end. But if you see a plus at the end, it's not going to be factorable, at least with real numbers. Maybe sometime in your math career, you might learn something about imaginary numbers, then you can factor it, but we're not going to have that much fun today. So when you see a plus there, you cannot factor it properly, at least with real numbers. So finish the rest of the three. The term that is used to describe these types of problems, at least the factoring, is they're called difference of squares. Difference of squares. And that's where that middle term has kind of disappeared. So I do want to kind of show you the language of this. Difference means subtract. So you're subtracting. You're subtracting perfect squares. So x squared is a perfect square. And 81 is a perfect square. That's just 9 times 9. So it's a difference. You're subtracting two perfect squares. And that's why it's called a difference of squares. So it works when there's a subtraction in there, difference. But if you see a sum, if you're adding them, that's not going to work. So you can't factor it with addition. So go ahead and finish these up, put those answers into Schoology, and you're all set. You've got everything you need for the test. There's one more assignment that you can choose to do for extra credit, and that's how to factor when the A term is bigger than 1. But you don't have to. It'd be a good idea if you do. All right, have a good rest of the week, everyone. Good luck on that test.